if you are interested, which I'm assuming that you are, you know your test is going to be on Tuesday. I'm going to talk about that in a lot of detail tomorrow. So watch this space. What we're going to look at today is trying to get as much of this finished as we can, and then tomorrow we'll get the last bit finished, and then whatever's left of tomorrow, we'll focus on the test, right? So telling you about the test and so on. So we're looking at the area between two curves, and there's your formula. Now, you don't get many questions or examples of these. In fact, from what I can see in my little changed list here, is that most of the time you only get 2 or 3 examples of any of these situations. So you've got to kind of get the gist of it just by seeing, you know, a few examples. So this is question 11. And that's the 2 guys, 2 functions, and they're going to be about the x-axis. So the formula for calculating the volume of revolution when you take this shape and you rotate it about the x-axis, it's very difficult to draw these things. So almost all of them in my brain look like very ornate napkin rings. So if you live in a household, which I don't, that has napkin rings, do you know how kind of weird they can look? So think of napkin rings. So first thing I would do is sketch the region so that I'm aware of what is being rotated, what area is being rotated. In this case, there are only 2 of them. If I go to Desmos, I'd get y equals x to the 5 would look something like this. And the square root of x would look something like this. And in this case, then, would you agree that the area that's being rotated about the x-axis is this I shape? You agree? Now, on Desmos, you will be able to find those 2 guys out. But I'm pretty sure you could figure that out yourself, isn't it? 0 and 1. Right, everything I need to know is here. I just need to know where it goes in the big scheme of things. So the volume of revolution of rotating this shape about the x-axis is the integral from 0 to 1, start to finish, pi, a guy called f of x that you then square, take away another guy, another curve called g of x squared dx. I'll pull out the pi and do the integral from 0 to 1. Okay, I have a red guy and I have a blue guy. Which one of those 2 is the f of x?
Red guy.
Red guy. So what you're going to do is square root of x squared, take away x to the 5 squared dx. The square root squared gets you x, and squaring that gets you that. And at this point, I'm going to just go dot, 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 dot. Would you agree that the hard part's over? It's just normal integration now. Power rule, off you go. Just out of curiosity, let's say that you're not very good at figuring out which one goes first and which one goes second, right? If you had accidentally switched these 2 around, and let's just say, let's pretend for that the right answer was 3/2 pi, just for argument's sake. If the right way around it was 3/2 pi, what do you think the answer would be if you had accidentally got them the wrong way around?
Negative 3/2 pi.
Right, and don't you know that negatives are impossible for volumes as well, because these are physical things. You never get 0 in a volume question. You never get 0 or negative numbers for that matter in area between, right? Because these are physical things. Of course, if you did that and you're 99% sure that's the only thing you did, in a test question, couldn't you just say, oops, 3/2 pi, switch the order? And I would say, okay, she figured out what she'd done wrong, or he figured out what he did wrong, you know, call it good. Saves you having to redo a question, especially if it was really ugly one, right? You don't really want to start at the beginning again. So if you know that's the only thing you've done, just switch it to positive number and write down a sentence along the lines of, You know, I switched the two functions around. And are we cool with that? Okay, let's move on to the other one, which is question 10. And question 10, if I can find the damn thing, here we go, has a function called 7 take away x squared and a line, in my case, y equals 3. And to save time, I'm going to just do it on paper, but you can imagine doing it on Desmos. Are we comfortable? Yeah, not the best drawing. Y equals 7 minus x squared. It probably should flatten a bit more, but that's fine. Where does y equals 3 go in this picture? Now, since this is 7 and Desmos would show you, can you imagine that 3 is about here? So the region that they're interested in is that region, agreed? Which kind of, if it had the Desmos, I would do this the easy way. Wouldn't we just click on Desmos and it would tell me what these numbers are? Agreed? Can you trust me that it's -2 and 2, but you could figure that out yourself? Okay, so we've got all the information. The volume then is going to be the integral from -2 to +2 of pi. Right, blue or red? Who is the f of x in this story? The blue guy or the red guy?
Blue.
Okay. If you have to think about it, draw one of those vertical rectangles. The top guy is f, the lower down one is g, right? That's how you can tell. Right, now the blue guy is 7 take away x squared squared. Take away. What goes in here for g of x? What do I write here and then square it?
3.
Yeah. I know that y equals 3 doesn't look like a function to you, but isn't y f of x or g of x, right? It's just a placeholder for it. Now, plug out the pi. I now have some issues. What do you think I'm going to do with 7 minus x squared all being squared? Because I can't, yeah. Can you trust me? It's 49 take away 14x squared plus x to the 4. Are you happy with that? Okay, I'm going to dot this one, although there's a little bit of work. Wouldn't you take care of these two numbers and make it 40 and then power rule it? And that is the end of the area between two curves being rotated about the x-axis. Do you, even although you've only seen two, do you get a feel for how this is going to work? Draw a picture. Make sure you've got all the information on your picture, like intersection points, whatever it needs to be, so that you know the start and finish. Once you've got it, try and remember who's the big one, who's the little one, right? Who goes first, F, who goes second, G, and then after that, it's pretty straightforward. So, where are we off to next? Well, there's a kind of theme to this. We keep going one way, then we go the other. We are now going to do this fella. Find the area, well, rotate the area, I should say, between two curves, but this time rotate it about the y-axis. And here's my picture. And let's start with a clean one. I think that's fair. Okay, so you're going to have your usual axes. And let's suppose I have my two curves, but I'm going to be rotating about the y-axis. So that's this axis. So I'm going to have a curve over here called x equals f of y. And then next to it, I'm going to have another one. I'll do it green. And it goes on like, whatever, that guy. And that's x equals g of y. And they're going to start at some number c. They're going to finish somewhere over here at d. So this region is the region that's going to be rotated about the y-axis. And it would look like a weird napkin ring, as all of them do. Now, based only on the fact that I've already told you what this is, you should be able to just use symmetry and a bit of common sense to create what the formula for this situation would be. Any volunteers?
The integral from c to d pi f of y squared minus g of y squared.
Would you all agree that that kind of makes sense? If nothing else, shouldn't math at least make sense, right? I'd be really surprised if this formula suddenly became something totally different. Because in a way, if I do that, aren't I now rotating about the x-axis? Right. So you wouldn't expect much, and there isn't. So what we're going to be doing is using this formula, which is very similar to that. And where's my question number? I've got to keep them handy. 9 and 12. Okay. Question 9. Oh, I will do 9, but I'm going to do 12 first. There's a reason for that. Now, in question 12, x is 2 take away y squared, and x is going to be y to the 8, and it's going to be rotated about the y-axis. I'm pretty good, not perfect, but I'm pretty good at doing y equals f of x's without needing Desmos. Would you agree it's probably a good idea to use Desmos when it's an x equals, because it's quite hard sometimes to visualize what the damn thing looks like. So if you give me a few seconds, I'll set that up and we can look at what we have. Okay, so I click on this and I do 2 take away y squared. And I forgot that you have to say x equals, or Desmos doesn't know what you want. And then x equals y to the power of 8. And I'll probably zoom in this a little bit, move it along a little bit. There, that's good enough. Can you see it's a pretty boring curve, isn't it? It's just like an egg. Now you take this shape, we need to click on there. Can you see that it starts at y in 1 and -1? Can you see the limits of integration? -1 and 1. You with me so far? Right, although you can't see this, I'm writing this down. So I'm writing the integral from -1 to 1, and I'm now writing pi. So I need to find f of y squared and take away g of y squared dy. Now the orientation is different this time, I understand that. Red guy or blue guy, which one of them is the f of y?
Red.
You're right, yeah. How do you know? How do you figure it out in your brain?
Because it's the function that's farthest to the right.
Yeah, that works. So the f of y one happens to be 2 minus y squared. I know that because there's a little color scheme here, right? So it's 2 take away y squared squared. And of course, the other guy is y to the 8 squared dy. Right, now return to my notes, and you should see that all the stuff I just mentioned is written down. -1 to 1, the red guy squared, take away the blue guy squared. You're comfortable about where all the pieces come from, where they fit. What do you think I'm going to do next? What am I going to do from
Foil.
here? Foil, okay. If you foil this guy, you get that. And if you do this guy, you get that. Is it okay for me to do dot, dot, dot now? You feel comfortable about how you would finish that? Moving kind of backwards now, because I said I would do it. I think it's question 10. Let me double check it. No, it's question 9. And give me a few seconds. Here we go. Try to find it here. All the zooming. Here we go. This guy looks wrong. He is not wrong, but he looks wrong. If you just scanned this, wouldn't you think it's one of those two, the area between two curves rotated about the x-axis? And the reason you would think that is because of the way the information is given. Now, I'm still going to use that information to draw the sketches because it doesn't matter how you rearrange an equation, it's still the same guy. Would you agree that y equals x squared is just a big happy face? And that y equals 4x would be a straight line. And the guy that we want is a little skinny banana. And can you trust me that that guy is 4? And this guy is clearly 0. Are you happy about my picture? You know you could plug any Desmos, I'm just saving time. The problem is the information needs to be written in a way that allows us to rotate the thing about the y-axis. So that's not the picture I need, or at least that's not the way to look at the picture I need. I need to know this number. And this number is 16, isn't it? Because I need the limits to be from y equals 0 to y equals 16. I also need the pi. I need to have a function called f of y squared, take away another guy called g of y squared dy. And almost everything that I've got is the wrong way around. So I'll pull out the pi. I've now got the y going from 0 to 16. Blue guy or red guy, which one of these guys is my
Okay.
f? Agreed? Now, problem. This is not the way these equations need to be written, so I can use them. This guy, for instance, is going to have to be called that. Are you happy about algebraically that if y equals x squared, x is the square root of y? What will this guy become?
One quarter.
Y over 4.
Right, y over 4 or 1/4 y. Agreed? Now, blue guy before red guy. Right, blue guy is him, so square root of y squared, take away the other one, 1/4 y squared. Are you comfortable about how we had to adapt the information to suit the situation? Now, make it look pretty before we worry too much about what to do next. That guy becomes y, this guy becomes 1/16 y squared. At this point, can I just go dot, 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 because it's easy to finish? Any questions right now? Are you happy about area between two curves rotated in the x and then in the y? You're comfortable? They're very similar processes, aren't they? If you can do one, you can probably do both. Last chance, any questions? Did you know that most mummies in Egypt are daddies? No, what? Come on. Most mummies in Egypt are daddies. Cassandra, help me out here. That's funny, isn't it?
I thought it was funny. I don't think our brains are ready for it because we're concentrating so hard.
Okay, I can't fault you for concentrating hard. It'd be hard for me to say, hey, stop doing that. Stop concentrating so hard. Okay, we have 2 more guys to do, so I'll cross that off my list. The last 2, of course, are going to be the hardest, as you'd expect. It's going to be the area between 2 curves, which we already have been doing. But what's the twist? Oh, parallel to the x-axis. So a line that's not the x-axis, but parallel to it. So this is going to be the area between 2 curves, rotated about a line, parallel to the x-axis. Oh, right. Now, what question does that? 14. Oh, forget 14. Let's show you the theory. Imagine that we have the 2 curve thing. So I'm going to have my usual y equals f of x here. I'm going to have my y equals g of x here. That's going to be at A, and that's going to be at B. Nothing different here, right? There's no significance that those 2 curves look the same. It just happens to be where I drew them, right? So can you imagine you've got your classic area between 2 curves? Now, if I said to you, rotate that about the x-axis, we know how to do that, right? We've done that. Great. So what's the new guy in town? The new guy in town is that you rotate it about a line parallel to the y-axis and make this particular line y equals, say, -3. Now, I should probably call it y equals, I don't know, f or something. But if I did that, there'd just be too many letters floating about that you might not get the gist of what's going on. So this one here is actually a placeholder for y equals -2, y equals -10, right? Anything that's got a negative number like that, right? Y equals negative somebody. Now, what does the formula for the volume look like when you rotate a shape about this axis? Well, it starts off the way you'd expect it to be, the integral from A to B, and it has a pi, and it has a something squared, take away a something else squared, and it finishes with dx. The difference here is that this is not f of x squared, take away g of x squared, or at least it's not only that. Let's take the furthest distance, which would be from here to here. How far away is that, right, using x's? Well, would you agree that from here to here is 3 units, and from here to here is f of x? So wouldn't that total distance be f of x add 3? Are you happy where the extra add 3 is coming from because of the axis of rotation has changed location? Are we okay with that? This is 3, this is f of x, so the whole thing from here to here is going to be f of x add 3. Okay, what's this second one going to be? What's that distance going to be then?
G of x also add 3.
Right, so there is a kind of symmetry to it. Suppose that line was y equals -10. Wouldn't we only change b to make these plus 10s? Okay, agreed? Now, If it was y equals 0, isn't that the x-axis? And if it was y equals 0, don't you get back to the usual formula? So isn't the x-axis just a special case of this formula? Now, that's basically it. That's how you will rotate a area between two lines when the guy's down here, right? And there's another version when the line is up here, but let's not worry about that yet. Let's focus on just the one that we've done. So hopefully 14 or 16 will look like that. Come on, keep going. $14. I overshot it. Okay. So in question 14, we've got the curve y equals x cubed, y equals 1, x equals 2, and is to be rotated about the line y equals -5. Now, always begin these questions by doing a sketch, either in Desmos or as I'm doing it physically. Are we good with y equals x cubed is roughly going to look like that? Are we cool with that? Now, if I do the line y equals 1, won't it be a horizontal line, something like that? So far, so good. I've got another line called x equals 2. So I should probably put that one a little bit further. There's one. And x equals 2. Can I pretend 2 is there? Okay, I'll move my scale around. Can you see that that combination generates this little triangle? X cubed, y equals 1, x equals 2, and we'll pretend that's x equals 2 going this way, right? And that's y equals 1 going this way. So I have my little triangle. Probably should have done it in Desmos, but too late now. And can we pretend that away down here is y equals -5? So this is going to be our axis of rotation. So our volume of this shape is going to be the integral from the start to the finish. Can you trust me that that's 1 and that's 2, because my sketch is really bad? Pi, somebody squared, take away somebody squared, dx. Okay, this is going to be a case of, put my little formula, that's a good idea. Shouldn't it be the one that's furthest up, add a number, and the number that's less, so add the same number, right? What number are we going to add? It won't be +3 this time. 5, great. Now, would you agree the blue guy, which is x cubed, goes first, and the little guy, which is just 1, goes second? Are you happy about that? F of x, g of x. That fella there is just basically saying g of x is 1, and that fella there is saying f of x equals x cubed. Right? X cubed plus 5, 1 plus 5. We good? Right. Making it look pretty. If you FOIL this guy out, you get an x to the 6, 10x cubed plus 25. That guy gets you take away 36, and you can do a dx. Are we good with ... now? I guess I could combine those numbers, couldn't I? Maybe get -9, but apart from that, power rule and done. The vast majority of the questions that we have done didn't the integrals end up being pretty straightforward? A lot of them were just power rules. So you're not going to have a problem with the end of these questions. Aren't you going to have the problem with constructing the picture and then getting the relevant information? That's where your problem's going to be, in my opinion. Anything about question 14 before I move on to the essentially the next one, which is 16? This is your chance. Anything? Okay, next fella then. Question 16. Or at least a version of it. Y equals 3 sin x. Y equals 3 cosine x. And the x's have to be between 0 and pi upon 4. And the whole thing is going to be rotated about the line y equals -1. Yeah, I think I can get away with not using Desmos again. I'll try my best to make it look good. Are you okay with that as being part of cosine x? I don't need to draw the whole thing. And if I go green, are we okay with that being part of sin x? Can you trust me if you did this in Desmos? That guy there happens to be pi upon 4. So if you take the area between these two curves from 0 to pi upon 4 and you put the whole package together, doesn't it look like an old-fashioned axe head? Are you comfortable about how this information became this? Okay. Then the volume that you would get if you rotate it. Oh, I forgot to put in about the line y equals -1. Right. Well, it's going to be the integral from 0 to pi upon 4 pi somebody squared, take away somebody else squared, dx. Okay, which one of them is the f of x guy? Red or it's kind of green, bluey green. Which one is the f of x in this story?
The red one.
The red one. So shouldn't it be cosine x plus what number?
It would be +1, but wouldn't it be 3 cosine x?
Yes, because I made an oopsie and you got it. Thank you for catching that now, brother Lair. Can we jump into the other one then? Because isn't it going to be just 3 sin x plus 1 as well? And this one isn't as straightforward as most of the integrals we've done before. 3 cosine x plus 1 squared take away 3 sin x plus 1 squared. It's not a trivial thing. If you FOIL this guy, you get 9 cos squared x's plus 6 cosine x's plus 1. If you do the same to that one and you FOIL it, you will get 9 sine squared x's plus 6 sine x's plus 1. And you get 9 cos squared x's, take away 9 sine squared x's, plus 6 cosine x's, take away 6 sine x's, and the ones cancel each other out. Well, that's pretty messy already, but that isn't even half the problem. I know how to integrate that guy. I know how to integrate that guy. That guy is a problem. So let's see if we can make them look pretty. Let's do a style points on trig. And when you do style points on trig, you have to figure out some other expression that's the same as it, but nicer. Right. Are you happy with me just pulling out the common factor in 9 just to make my life easier? Somewhere in 142, and I know it's true because I teach 142 from time to time, so I know I do it. Cos squared minus sine squared is somebody. And if it was plus, it would be 1. If it was cos squared plus sine squared, it would be 1. But it's cos squared take away sine squared.
Would it be the cosine of 2x?
And it would be. Does that ring some bells? The double angle formula, cosine of 2x. So do you see this guy that we have down here? He now becomes pi, the integral from 0 to pi upon 4, 9 cosine of 2x's, plus 6 cosine x's, take away 6 sine of x's, dx. So far, so good? I'll keep the pi there. I'll do from x equals 0 to pi upon 4. And let's take them one at a time. What is the antiderivative, also called the integral, of negative sine x? Negative sine x.
Negative cosine x.
Are you 100% sure?
Well, if it's negative cosine and then it becomes positive cosine.
There we go. What about 6 cosine x? Anybody want to have a shot at that? The antiderivative, right? So you have your antiderivative Helen here, integration Helen. 6 cosine.
That one is sine x.
That one's positive, as you're right, sine x. How would you do 9 cosine of 2x? How would you find the integral of that guy?
You'd have to use u substitution.
Right, and if you did use substitution, can you just trust me? Because I don't want you to have to go through the lines of working. You end up with that. You can also do what's called a linear shortcut method. Right, at this point here, can I leave it? Would you agree it's just a matter of plug and chug and see what you get? Are we good? Right. Now, the 2 questions that I gave, the axis that you were rotating the thing by was below the x-axis. I'm now going to show you the other situation, even though we don't have an example in the homework to show you, but it is possible, so I want you to be aware of it. So here is my y equals f of x. I should have made this line much bigger. And I have another one down here. Here is my g of x. Start at A, finish at B. I'm not doing anything new yet. But we are going to rotate it about a line above the axis, above the shape. Now that does change the story. I mean, the formula that we used earlier, which I now can't find one. Right, bear with me, I'll hopefully come across one in a second. How can I not find things when I want them? Here we are. There we go. Isn't this what you did when the line was below the area, right below the x-axis. What do you do when you rotate above the x-axis? Well, the formula is v equals, it's still a to b, and it's still pi, and it's still somebody squared, take away somebody squared, dx. But these guys are not going to be them. If you take the axis of rotation and you find the vertical distance, do you see that there are two distinct distances? The axis to the red curve and the axis to the green curve. You see that? Those are going to be the fellows that go here and here, right? So whatever that length is, it goes here. I'll call that guy big and I'll call that guy small. So we have to find the length of the big guy and then square it, and the length of the little guy and square it. In terms of x, if you wanted to find the distance from here to here, wouldn't it be 5 take away g of x and 5 take away f of x? And you can call anybody you like f and g, it doesn't matter, but that's what we've got here. Do you see that is going to be not the function add a number, but the number take away the function? Now, if you switch these round by accident, won't you just get the right answer but negative? So, you know, it's not a big, horrendous mistake if you, oh, I should have done this one first, not that one first.